Good evening, everyone, and welcome to UDC Foundation's Week of Giving, where we spotlight the School of Engineering and Applied Sciences. Thank you so much for joining us this evening. We really appreciate everyone's participation in our first ever virtual fundraiser for each school and each college during this week. We're going to shine a spotlight on their programming, their research, their incredible students. I cannot wait for you to hear from the engineering ambassadors of the School of Engineering and Applied Sciences. You'll hear from our awesome deans, and I'm so very fortunate to have with us Dean Deva Shetty. He has been at the helm of the School of Engineering and Applied Sciences for some time. He has over 35 years of professional experience in engineering, not just in the US, but several countries. We are so very fortunate to have this outstanding academic leader at the helm of SEAS. And tonight we're going to hear more about their degree program, more about their research, and learn while your partnership with UDC, with the School of Engineering and Applied Sciences, provides extreme hope, incredible impact to keep us moving forward and just being a world-class education of higher learning here in the District of Columbia. So without further ado, I'm going to turn things over to Dean Shetty.
Thank you, Ms. Palmer. I am also excited about the event today, and this is the first event in the last 8 years since I had been here. We were wondering why we didn't have any such events before. Thank you, Ms. Palmer, as well as Vice President Trapp for organizing this event through the foundation. I have with me some of my colleagues also, some chairs and other faculty members. We'll give you a sort of a bird's eye view of what is happening in the school in the last few years. In fact, in the last few years, we have really emerged as a new school. I will show some slides so that in order to save time, we can go through it pretty quickly. I think people can see it, okay. So first, I think what has been happening in the last 10 years or so, you may recall like there was a formation of a community college and a flagship about 10 years ago. So there had been changes in the university leadership with President Mason in 2015. And there was a strategic plan from DC mayors where our programs were very much linked with the DC mayor's plan, which came into existence in 2014, followed by President Mason's new initiative, like a new strategic plan called Equity Imperative in 2018. Then in 2019, we had the new chief academic officer, like Dr. Lawrence Potter joined us. And then we have several other changes which have happened in the school. So we had separate departments of civil, where a combined department of civil and mechanical engineering, which were made into two separate departments, civil and mechanical in 2013. There had been new leadership of the Department of Mechanical Engineering, Electrical Engineering, Computer Science, and as well as civil engineering. We had the appointment of a new Director of Student Engagement 2017, and we have a new Associate Dean who joined us in about a year ago, little more than a year ago, 2019. We got a lot of support, especially for accreditation, especially from the mayor, to renovate and equip and update our equipment, especially SEAS laboratories. There had been major funding, extramural funding, especially research funding from SEAS faculty, especially in the last 5 years. If I summarize, like our research and grants have increased multifold, in the last 5 years, especially through faculty participating in cutting edge research and applying to places like NSF and Department of Defense and Department of Energy, so on. And we had like a number of faculty had been hired because of retirement, especially in the last 5 to 7 years. And our teaching had been changing with more emphasis on learning and also partnership with the industry. Our student enrollment has increased. It has nearly doubled in this time frame. We have started new degree programs, undergraduate programs, graduate programs, and now a new PhD program. One of the things we had been doing is to increase the residents from DC through various mechanism and partnership with community colleges, DCPS and on. So it had been steadily increasing, and we expect this trend to continue in the future also. Now, looking at the degree programs, in civil engineering, we have Bachelor of Science in Civil Engineering. Then we started a Master of Science in Civil Engineering, which is in second year. In electrical engineering, we have conventional BS ABET accredited electrical engineering program, and the Master of Science program, which had been there for the last 7-8 years. And then we have introduced a new program this year, which will go into existence. It is a BS degree in computer engineering, which has been approved by the Board of Trustees, and it will be implemented in fall. In mechanical engineering, we have BS in mechanical engineering, and we started a BS in biomedical engineering about 4 years ago, and we graduated the first set of students this year, and we have gone through ABET accreditation recently. We're likely to get ABET accredited this year. Then we also have a Master of Science in Mechanical Engineering, and we have a couple of students in PhD program also in Mechanical Engineering. And the fourth department, CSIT, Computer Science and Information Technology, has a BS in Computer Science, and then the BS in Information Technology, MS in Computer Science, and also there are a few students working on PhD in the area of computer science. And one area which will grow this year is cybersecurity. And we have a new proposal out there, which has gone through the Senate and about to be approved by the Board of Trustees in the area of cybersecurity, both at bachelor's level and master's level. Master's level, it is likely to be both hybrid as well as online. So these are a quick summary of the academic program. So continuing about what is happening is there had been implementation of collective bargaining agreement called Master Agreement 7, Master Agreement 8, which happened last year. Our facility renovation first phase was completed in 2016, and we have some more needs, and we are discussing about the more renovation in the next year or so. There had been transfer agreements with the regional community colleges, especially there are 4 major colleges around here, Maryland and Virginia, and we are having articulation agreement with them. And we started an undergraduate biomedical engineering. One new area we started is a accelerated master's, which gives the ability for a undergraduate student who's in the junior year to think of master's and then apply for master's early. So some benefits are there by combining BS and MS together. It is called accelerated master's in all the undergraduate areas, electrical, mechanicals, civil, and computer science, and additional graduate programs, master's and PhD. There had been a lot of focus on curriculum innovation. Our accreditation agency emphasizes on continuous improvement. So we had been working on that continuously. We have become good at it. And recently there had been an accreditation visit in the last fall. So they were able to see some of the modification and improvement we had done. We are partnering with companies to have externally sponsored projects which can be done by our students before they graduate as a senior undergraduate capstone project or even master's thesis. So we are working on that. This is a new approach now, and we are a little more aggressive in this area. We are also looking at the curriculum to change the curriculum to make sure the curriculum has the contents of entrepreneurial mindset. So it is not in one course, it is in a series of courses. So we are able to create students and graduates with entrepreneurial mindset. There had been focusing on tutoring, mentoring, and early alert system put out Dr. Latham's office, so which is in place so that if the students are in trouble, we are able to recognize it so that we can come in and improve it. We also involve and emphasize a lot of professional activity through professional societies, we encourage students to participate in these activities and compete in different type of projects. One major thing which has happened is like a partnership with agencies, National Science Foundation, National Institute of Health, NIST, Air Force, I mean, mainly Air Force and Defense, Department of Defense, we can say, NRL, NASA, Department of Energy, partnership with other hospitals. So this had been a big jump in this area. And this year, in fact, the faculty 2020 onwards, faculty were able to get grants up to $30 million. So which has resulted in several centers. So one of the centers is a DOE center in partnership, Department of Energy partnership for post-processing. It is like a consortium along with other universities, including Morgan State and then Howard University. There is a program with the NIST, actually, program to do research. It's like about $7 million grant to do for 5 years, to do high technology type of research, and also for ability for the student to work in NIST. There is a major National Science Foundation grant called CREST Center for the people to do work in the area of nanotechnology, research and education. And then there is a NASA CAMSTAR Center for Advanced Manufacturing and Space-Related Technologies. This is in its second year of existence. Again, a major grant. And some of these center grants are likely to be renewed. You know, NSF grant is a 5-year grant. NASA grant is a 3-year grant, likely to be renewed. But it is helping a lot of students. In fact, one of my colleagues is going to, Dr. Zhu is going to join and talk a little more about it. Then the recent grant is from NIH, which is the facility grant, $5 million, like in the area of Center for Assistive Rehabilitation, especially to increase our equipment and then the facilities in the School of Engineering and Applied Sciences. Mainly overall, these grants are helping us to grow the research capability, exposing the students to collaborative cutting-edge research and development with industry and the government, and promote the pursuit of degrees and development in preparation of diverse research-capable workforce, and also emphasis on underrepresented minorities. You know, so if you want to summarize like some of these 5 center grants, actually the outcome of this will be like this: promotion of undergraduate research at UDC, increasing the student internship, boosting the STEM enrollment, and our ability to produce more underrepresented minority graduates so that they have research experience before they graduate. In addition, all these grants are helping us for creation of facilities for faculty and the students. And again, this addresses the major needs of the country, you know, because there is a need for STEM workforce. That is what we are really helping us to develop. So again, what are our pride points? You know, like I'm just listing those 5 centers, but there are many more than 30 different types of grants our faculty members have got from various agencies. But these are the major grants: NSF CREST Center grant, NASA grant, Department of Energy grant, NIST grant, NIH grant, and there is one more grant. Center grant is just about to come from the Department of Defense. The second pride point is a new PhD program. So PhD program is in its second year of existence. We may be able to graduate the first student, maybe they graduate by next year. So which is both in engineering and computer science, but there is a lot of interaction because we are able to produce a PhD in engineering with also fairly a good knowledge of computer science, and the other way around also. And again, enhanced partnership with the industries, and developing some of these grants have resulted in new technologies. And then we are going to look for possibilities of commercialization. A lot of this research are able to help us in bringing publications, you know, and then these publications are with the students, with the undergraduate students before they graduate. Our students had been participating in competitions and winning awards, and all around. They had been doing very well in all the areas. So since I didn't have that much time, I'm not able to list each of them. We had been able to do public service. In fact, during the COVID time, I think our faculty and the students rose to the occasion. We were able to develop about 1,000 face shields to the mayor's office. So, and what are our current challenges? Current challenges, of course, is the student financial needs. That's why we are here, because some of our students are not as rich as some of the institutions I had been in private universities before, but comparatively our students are not as rich as those students. So they need really financial help, And again, some of these issues are heightened because of the COVID-19 environment, So that's why this is an overview, and I think we deserve your support. So that is my appeal. And I want to turn over to my colleagues to continue from here. Okay, thank you.
Thank you, Dean Shetty. At this time, I believe we have with us Dr. Wang that's going to talk to us about geotechnical engineering research.
Right.
So you would stop sharing your screen, Dr. Shetty.
Okay, thank you.
Thank you. Let me see how I can share the screen. Can you see my screen now?
Yeah.
Okay, sure, great, sure. Hello, everyone. My name is Lei Wang. I'm an assistant professor in the civil engineering department at UDC. So basically today I will give a brief introduction of the geotechnical engineering research we conducted at the UDC. So first, if some of you may not know what is geotechnical engineering, it is basically the focus of geotechnical engineering. We are concerned on the design, construction, and management, all kinds of infrastructures that is built inside the soil or built on the soil. For example, you can see the pictures of the geosynthetic retaining walls for bridge construction, for the slope stabilization problems. Also, geotechnical engineering, we are dealing with geological hazard like the earthquake. You can see this one is like after earthquake happens, the soil liquefied, so cause damage to the buildings. And also we are involved a lot of underground engineering, such as we build the tunnels and for the transportation as well as the water resource engineering, and also build the deep excavations for buildings. And also we working on the stability and also seepage analysis of the earthen levees and these problems. So my major research focus is to evaluate and explore the fundamentals of the geotechnical engineering systems, as well as to develop innovative solutions for the sustainable and resilient geotechnical infrastructures. My major research area include 3 research areas. The first one is I'm working on a lot of research on the reliability-based design risk-informed decision-making for the geotechnical infrastructures. So like we can achieve the robustness and the resiliency of our infrastructures in the face of multiple hazards. For example, the earthquake hazard, the flooding hazard, all kinds of other hazards. Another one is I have been working on a lot of the numerical modeling as well as centrifugal modeling of the geotechnical and underground infrastructures, and also working on the geological and geotechnical hazard mitigation. The third part of my research is to work on a NASA project to develop the discrete element modeling method for the geosoil interaction. So lunar soil, for example, lunar soil, many times we call it the lunar regolith. So we evaluate how the soil and the geo are interacting, so like we can develop the efficient, energy efficient tools to explore the outer space. So these are some selected grant I have been receiving. So a lot of these grant has been very supportive to all the students, and also set up the geotechnical engineering lab. So we worked on like the risk and resiliency of the infrastructures, especially the earth dams and levee, these problems. And also we developed the geothermal systems for the sustainability, and also we are working with NASA grant to develop the geotechnical tools for the in-situ resource utilization based on whatever the material available in the moose, so like we can use it to build our permanent base there. And also we work on getting the high advanced equipment for our research on the biomitigated ground improvement. And these are some selected publications, So a lot of these publications, actually, they are co-authored with even our undergraduate study. They are be able to publish some papers. So these are including like the robust design, reliability-based design for the earthen levees and the footings in face of different kinds of hazards. And also we are working on the geosynthetic retaining walls and underground engineering. And also we're doing like things related to the soil liquefaction and how the geological structures, how it will affect our soil liquefaction and its effects. So this one is a research, just a snapshot of the research about the retaining wall design. So actually one of the students who worked with me on this retaining wall design, he was admitted to the Columbia University. So we worked on developing the reliability based framework, so that like we can design our retaining walls, the geosynthetic retaining walls, based on the failure probability rather than the traditional deterministic factor of safety. And also I have been working on evaluating the retaining walls that is backfilled by shredded tears. So basically we can reuse some of the waste materials for our construction of geotechnical materials to evaluate, for example, the earthquake load, how the earthquake load it will affect on our retaining wall design, so that we can achieve the robustness of our design. Another part I'm heavily working on and also still, spending a lot of time on doing this research is for the earthen levee systems. So one thing is, these are some like seepage as well as the stability and the settlement of the earthen levees in face of the flooding and the earthquake hazard. And also, I'm based on this numerical modeling, like finite element modeling, I will be able to develop the relationship between like factor of safety as well as failure probability, how they are depends on the earthquake intensity, how we can do the design based on based on our targeted failure probability under the earthquake hazard. Another one is have been working is to not just to consider the earthen levees, I also consider the flooding walls on top of the earthen levees, then to evaluate like different flooding levels, variations on the flooding levels on our stability of the eye walls combined with the earthen levee system. Another part of my research I have been working on is to optimize our design for the pipe foundations, so like we can achieve the slope stabilization, because many times you go to the mountain areas, there will be likely to be the slope stabilization problem. We will be using the pipe foundations as lateral retaining structures to stabilize these slopes. One thing is I'm conducting a lot of finite difference measure to evaluate, if we have the if we do not have stabilizing pipes, what will be the factor of safety or failure probability. After our different design of these stabilizing pipes, how our factor of safety as well as failure probability will change. And based on these results, I'm develop a robust design-based procedures so like we can optimize our design for these pipe foundations, so like we can achieve not just the safety of our slope problem, also we can achieve the robustness as well as cost efficiency. And another part of my research is I have been working with the NASA to develop the discrete element modeling for our drilling process into the lunar regolith. For example, you can see these are some pictures. For example, when we are drilling into the ground, lunar regolith, we're using the actual size of the lunar regolith in our discrete element modeling. So we will evaluate, for example, when during our drilling process, how will the soil particles, the velocity, displacement, as well as how the force chain, because the force will transfer from the drill to the soil, how this one will be changed. And also, yeah, we also evaluate, for example, different geometries. For example, this we have angle geometries. We use the size of geo that has been used by the NASA in their real applications. We evaluate, how the soil and the lunar regolith will interact. So we can, based on these simulation results, we want to optimize our design of the geo so that we can achieve the maximum energy efficiency for our lunar exploration. Okay, that's all for my presentation. Thank you.
I really appreciate your presentation. That definitely helped me understand more about SEAS and what you offer. That's some really interesting work that you're doing in SEAS, and I really appreciate it. Next, we're going to hear from Dr. and forgive me if I'm not saying this right, Dr. Sue,
yeah,
on space-related technology.
Yes, you're right. Good evening. Yeah, thanks for inviting us. So let me share my screen.
okay.
All right, so yeah, so my name is Jiajun Xu. I'm a associate professor in mechanical engineering department and also the director for this NASA ChemStar Center. Very quickly, this is a presentation on behalf of the team that to share with you the progress we have made. This is the second year of this fund, so we want to share with some of the progress and how we have supported our students. The vision of this grant when we proposed to NASA is to help transform UDC from a conventional undergraduate teaching university to a state-of-the-art minority serving and a PhD granting research institution. So the way we do that is by carrying out collaborative research partnership in advanced manufacturing. I will mention what it is. And also we want to implement experiential learning curriculum and activities to our students. So on the research part, we are focusing on advanced manufacturing. Advanced manufacturing includes additive manufacturing, which is people usually call 3D printing. And the other aspect of it is nano manufacturing, which is to use nanotechnology to fabricate different material and structures. So we use those two techniques, we call it advanced manufacturing, to enhance the capability of NASA future missions. So that's our research goal. For the educational goal, we'll try to train highly diverse and knowledgeable STEM students from undergraduate to doctoral level. And we also provide a pipeline to help them to pursue a career in STEM and also NASA or aerospace in general. Those are the four focuses of the center. We work on research projects. As I mentioned, we have additive manufacturing or 3D printing, nano manufacturing, and also we're focusing on the space technology related research. And also we are also interested in how we can provide those educational innovation through different courses, different projects to our students. And we also want to build partnerships and help our faculty to develop, have professional development, and also provide research facilities to help secure additional funding. And the last but not least is to recruit and outreach to the local DMV schools and also other neighboring university and community colleges. These are the four main areas we have been working on. So we provide pathways for our students and from partnering universities to NASA and aerospace industry. And we modify our curriculum with courses that focus on AM and also some NASA projects to our students. And also we have been participating in various NASA sponsored competitions. Here has one is called NASA Human Exploration Rover Challenge. We have been doing this for almost 5 years now. And we also have completed successfully at the RASCO competition. And this year we have 2 NASA Minds student teams in the competition. And the fourth one is to outreach to the community, as I mentioned earlier. So the research rely on different labs. So thanks to the support from the school and the university, we have a new lab space we call ChemStar. And also we have a metal additive manufacturing laboratory, and also tools we can do post-processing. And we also have a nano fabrication and characterization lab with clean room and other state-of-the-art tools we can use. And as I mentioned earlier, we're focusing on partnership. So we're working with different partners to further develop the center. So we have some national labs and centers we're working with, some NASA centers, they're also NIST. And we also have some universities we're working with on different levels. And we also have industry working with us, helping with different the research projects and student supervising. And then also some local high school and community colleges are working with, especially on a lot of outreach and activities. And very quickly, this is some of the highlights. As you see on the first left, top left corner, that's our student, Jaime, is giving a demonstration to the local high school students to our metal additive manufacturing lab. And he is just showing them one of the pieces we developed and printed here at UDC. And in the middle, you see there's students and faculty wearing this red T-shirt. That is the UDC rover team. And this is, I believe, 2018. The team went to Huntsville, Alabama, where the Marshall Space Flight Center is, to compete with about 100 international and national teams. And the team completed the course and finished in number 7, I believe, in the competition. So this really just, you see the rover students are riding on are completely designed and built by our students. So that's very proud of their success. And over here on the top right corner, that is our student Jaime again, giving this workshop on advanced manufacturing to our students and faculty during the spring break last year, right before the whole pandemic started. And over here, that's another student, Giancarlo. He is now at the Cornell University, studying PhD in mechanical engineering. He was the team lead for the rover competition team here, and he is showing the rover to some high school visitors as well. And over here in the middle, that's 4 students, senior mechanical engineering seniors, went to visit our industry partner on their capstone project. And the last one over here are some of the training, some of the equipment we have received, and our students are just learning different technologies to help with their study here. And just from more pictures of what the research activity we have been doing in the lab. And the other aspect is research. So as you see here, we have over here on top, you see that we have students showing this additive manufacturing workshop. And over here, this middle one shows the students went to attend an international conference hosted by NASA to interact with different their peers. And over here, there's just some other additional activities we did with the students to increase their interest in STEM. And also some of the guest lectures and also the RASCO competition we participated previously. And we also support our students. As I mentioned earlier, we provide support for them to do internship at NASA. It's just one of our 9 students last year. who did an internship at NASA. And here's another one from Civil Engineering Department. He's also last fall finished his internship at NASA headquarters. And this is some picture showing you the some of the curriculum we changes. One of the things I want to highlight here is that in our Intro to Engineering course, our colleague Dr. Klein has been integrating different advanced manufacturing technique to the student competition, and they all have enjoyed learning this technique in their class. I move on to the next one. So we also do a lot of outreach to reach out to the community to help them to understand what we do here and how can get engaged. So here are some just activities. And I want to highlight here that in the past year, this past summer, despite the challenge from the pandemic, we were able to host 2 summer workshops to the local middle school and high school students. So one of them is focusing on learning Tinkercad, which is a 3D modeling tool, and how to use metals, the plastic 3D printing to produce the parts. And another one we had also focusing on 3D printing, but we had also speakers from NASA to share with their career passion and how they can get involved with NASA. So all the things I'm showing you here is just want to tell you that we are doing all we can with the support from internally, from outside, to support our students and help them to become successful. I think this is my last slide. So I will just stop here. And if you have any questions, I'm happy to answer.
Very much. Thank you. Thank you so much. Really appreciate you sharing how SEAS is in the communities, in high schools. And I understand that we're going to hear from your ambassadors who's going to share a little bit more. Next, we'll have Dr. Kate Klein to talk to us about high-tech partnerships with the National Institute of Standards and Technology.
Good evening. Just want to make sure everybody can see my presentation.
Yes.
Yeah, so this is a very quick presentation. I just want to give you a little bit of orientation about this program, this very unique program that we have at UDC, partnership with NIST. So I don't know if anybody recognizes this image here, but this is an aerial view from 1952 of the corner of Connecticut Avenue and Van Ness. So this is before UDC was created. That former site the site that UDC is on actually was the National Bureau of Standards. And so UDC's land grant beginning really has a nice tie-in and a firm connection with what is now the National Institute of Standards and Technology, formerly known as the National Bureau of Standards. So we hope through this PREP program, we've been establishing and cementing that relationship with NIST. The Professional Research Experience Program, or as we call it, the PREP, UDC partnership, really engages students and postgraduates at the baccalaureate, as well as the master's, PhD, and graduate postdoctoral levels. So through the whole range of levels, students and recent graduates and even faculty can perform research at NIST and get paid through an internship type of experience. So let's see. The vision is really to prepare a diverse, research-capable workforce that's increasingly inclusive of underrepresented minorities. So in 2018, we were selected through the general call of grant applications as one of 7 schools nationwide. Brown, as well as Georgetown, University of Maryland, Montgomery College, etc. So we were the only HBCU lead that was granted this partnership with NIST. And so this cooperative agreement was awarded at nearly $7 million for over 5 years that supports only personnel costs. So this is essentially a program where our students and staff members will go to NIST to perform research and work on collaborative research projects. So the goal is to leverage our research expertise at UDC. And so this is some of the areas that UDC has expertise across the different C's disciplines, as well as computer science and IT and engineering, and can even go into other areas such as chemistry and some of the biological areas. So we can interface with the different laboratories at NIST, such as a material measurement laboratory, physical measurement laboratory, engineering, and the IT and computer science fields. So basically, wherever they have needs, they can send us these solicitations to fill those positions via our PrEP UDC program. So just a few quick highlights. The biggest impact I think that this program has is that the internship experience, I think, is what really and truly makes the most difference in the ability of students to mature, explore career paths, and most importantly, make them competitive in today's job market. So this program really cements that relationship with NIST and the ability for students to get that sort of off-campus experience within the workforce community and get that hands-on training that they need to be competitive at all stages in their educational path. So that's what makes this program really unique. So students and former graduates can have fellowships of variable duration, and they could be at the, like I said, the undergraduate level, post-baccalaureate, postmasters, postdoctoral, as well as faculty positions through this program. So that's pretty much in a nutshell what the PrEP program is, and I'd be happy to entertain any questions later on.
You really appreciate your presentation. We're going to move on to the Engineering Ambassadors Program. I love hearing from our scholars, our students. They are courageous, they are bold, they are our future leaders, and they demonstrate that daily in Firebird Nation. We have with us, I hope I'm saying this right, Scarlett Vasquez is going to talk to us about the Engineering Ambassadors Program.
Hello, everyone. Thank you for having us here today. I'm very excited to be here. I'm Scarlett Vasquez. I'm the president of the Engineering Ambassadors here at UDC, and I'm joined by my partner, Vice President Natalie. Are you here, Natalie?
Thank you, Scarlett.
So we're here to talk to you guys about the Engineering Ambassadors Program that has been running for a few years now and is doing really great. So let me start our presentation. So the purpose of the Engineering Ambassadors is to promote STEM to high school students in community colleges, as well as the University of District of Columbia STEM degrees and resources. We are funded by the National Science Foundation. And about our team, we are made up of 14 undergraduate students that are serving as engineering ambassadors from various branches. We have civil engineering, mechanical engineering, electrical, and computer science. The leadership is composed of myself, Scarlett Vasquez as president, Natalie Gallo as vice president, Danilo Nascimento as administrative assistant, Iris Hernandez as treasurer, and Christine as social media. I'm happy to say that some members are here for support, which I'm very grateful for. I appreciate you guys. So in terms of activities that we perform, we have conducted over 15 activities, outreach activities in person and virtual throughout these 2 years. for the District of Columbia Public Schools, Northern Virginia Community College, and Montgomery College. Prior to the pandemic, we would host high school students and allow them to come into the school and give them a tour of what UDC has to offer. That includes the labs and just expose them to like UDC environment. We would visit the campus and their campus and interact with them, do STEM activities to just plant the seed, just plant the seed of STEM, to just plant the seed of STEM and just basically get them to participate and just get some experience and knowledge of what it's like to be a student in engineering, as well as what it would look like after you graduate based on our experience. So this was an activity that we had with the students last year before the pandemic. We were hosting students from, I believe it was Coolidge or Woodson, that we ended up doing a tour of the campus and a hands-on activity, which was the shake table. It was a great event and they were really happy. It has helped us build relationships with DC Public Schools and for them to get to know us better. Now I'll pass it over to Natalie, who will continue the presentation.
Thank you, Charlotte. So as you can tell, that was something that we were able to do prior to the pandemic. Now we definitely get a little more creative with the demonstrations that we do since they're all virtual. So we still try to make it as interactive as we can. For example, I did, you could see on the top right, I did bridge loading. So I did like different bridge designs and I would ask them like, oh, which one do you think would hold the same weight, like in a better way? And then I would kind of like change it up. I would like stack some books on top and say like, oh, how many do you think, you know, could it hold? Scarlett did one that was really cool with sand. She showed how you can stabilize it by adding or removing water. So we definitely get interactive with them and they enjoy it because it's not just, you know, them listening to another PowerPoint presentation. Next slide, please. Okay, so this is the risk and resilience workshop that typically we do over the summer, and we do like to do it in person at UDC. Unfortunately, right now because of COVID, we do it online. So it is a week long during July, and we have different kinds of presentations. We try to reach out to the teachers from the high schools and see what kind of things that they would think they would be interested in us hosting. We do games, everything that we could try to do to make it more interactive for them. Okay, next one. Okay, so this is just a typical breakdown of how we organize ourselves throughout the semester. Of course, we want to be as accommodating with the high schools as we can. We also do Nova and Montgomery College. Those we do more as like giving the breakdown of the courses that we do. We get a little bit more into the specifics since typically those college students are already taking some kind of STEM related classes. So we tell them, oh, okay, you know, if you're taking these kind of classes, you will see this later on in this kind of class. So we definitely try to bridge that gap in between for them. So this is just a little breakdown. And typically we do it on a schedule that most of the ambassadors can attend. That way we get more interactive with the students. And you can see, which one was this one? Fall 2019. And that one, I think, Scarlett, we did in person, right?
Yeah, that one was in person.
Okay. Yeah, and then the fall 2020, all of those we did virtual. So some of them we did go to their high school or they would come to UDC. And now, of course, everything is virtual. Okay, let's go to the next one, please. So some of the benefits that have come from being an ambassador, We all know that in school we learn our hard skills, but this is something that has been really great for us to build our soft skills. We practice teamwork, we organize our teams together, we organize our PowerPoints, our presentations. So it definitely has helped us strengthen those skills, which is definitely translated to our core classes and even for our future jobs as well. I always like to tell people that this is something great to add to your resume. Anytime I have an interview, they always ask me, what are the UDC engineering ambassadors? And I love talking about it. So I make it a point to any ambassador, hey, you got to put this on your resume, use it to your advantage, talk about it at your internship, talk about it at your job interviews, because it really does show your leadership skills. It shows how, you know, we're giving back to our community. We're trying to educate the next generation. Of course, we want to diversify our field as much as we can. So we're definitely educating the youth by doing these sorts of activities. And it also provides networking opportunities. So I always tell everybody who wants to be an ambassador, it's a win-win because you're giving to the next generation and it's something great for yourself as well. Right, let's go to the next one. So if you have any questions, Dr. Wang is our director, Scarlett is the president, and myself as the vice president. And this is our contact information. So we'll take any questions at the end for anybody who has any. And you know, if Scarlett has anything else to say, but thank you everybody for listening.
No, thank you guys. Thank you, Natalie. If you have any questions, feel free to ask. We're here to provide any information and we will be happy to.
That was wonderful. I'm also looking at the chat, and I think that you did answer the question with regards to how SEAS is involved in the community and in schools. And I really appreciate your leadership and your willingness to work with DC public schools. I'm guessing you're probably in DC charter. I think that's wonderful because as you stated, it's about cultivating that next generation of engineers. And I hope you don't mind me saying this, but it is Women's History Month, and we're always talking about getting women involved in STEM. So this kind of makes me feel very optimistic and hopeful that the field of engineering is diverse, and we're cultivating that diversity here at the University of the District of Columbia. Can I just ask the two of you really quickly, like, how did you get involved in engineering, in STEM, and why did you select the University of the District of Columbia?
I guess I'll go first. So I got involved in engineering because I was initially interested in architecture, and I've always just been attracted to math. I don't know, one thing led to another, and as I stumbled through, I ended up finding civil engineering. And I chose the University of DC because I am a DC public school alumni. So I went to school at DC. I'm one of the few that we have left here that was raised here. So I always learned about the school, and I just decided to come here, and it was just a great way to continue with my studies.
Yeah, I also started as an architecture major back home in Florida. My father was a civil engineer, but I'll be honest, I never understood what he did at his job. And my mom was an architect back home in Columbia, so she would always help me with my school projects and kind of like the design aspect of it. Later on, when I got to high school, I realized how much I loved math and I wanted to do something more technical. So I still didn't really understand what everything in civil engineering has to do with, but I just kind of like jumped the gun and went for it. And I ended up loving it, and I'm so happy to be graduating this May with my civil engineering degree. So is Scarlett, she's graduating with me. And, you know, we always say it's hard, but it's, you know, now that we're at the end of our, you know, degree, it's so worth it. So we definitely want to spread that message. And I ended up at UDC because I actually live in Maryland, but I'm close to the campus. And honestly, I wanted a really good education, and I knew I wanted to go to a public university. I didn't want to have to graduate with a lot of debt. And I'm so glad I found UDC. Even though our engineering program is smaller, I think that we can grow it. And I've made great friends. Scarlett's like one of my best friends now. So I'm happy with the connections that I've made here.
And just to add to that, I think there's a question in the chat from Ms. Ann Langford. She asked, do the engineering ambassadors find opportunities to mentor students once they become UDC students? I think that's definitely something to think about for the future. What we're doing right now in our presentations is before we do any activity, we have an introduction panel where each of the participants introduce themselves, their field, and then we have a theme. And some of our themes have been, what was one course that was really hard for you and how did you get through it? What was something that you didn't know about UDC and what happened when you learned about it? Like things like that. So it's giving them insight to situations. I know there's been times where even the teachers have asked, like, what is something that in your curriculum you didn't learn, but you learned based on experience? So we shared those kind of things. And I think that's also part of mentoring them and letting them know what UDC is about and the programs.
Well, thank you again. And yes, I am a proud graduate of the prestigious University of the District of Columbia, and I am looking forward to welcoming you all, both of you, to the prestigious ranks as alumni. And yes, a great education and not a whole lot of money. That was an easy decision for me, a win-win. I cannot tell you how awesome it feels to walk across that stage and your pockets are so light. Thank you so much for your presentation. I am so inspired, and I hope that everyone who has tuned in, that you are inspired as well to help Firebird soar. We really need alumni, our friends, family of Firebird Nation to please donate to Seeds tonight. I'm gonna put on the screen momentarily the link to donate to Seeds. But if you go to Seeds' website on udc.edu/Seeds, there is an opportunity there to give. On their donation page, there is the address if you want to mail a check. But your donation provides so much hope and a deep impact that benefits our students and our faculty. We can't do it without you. And so I'm hoping that the alumni that are tuned in, I have alumni on Facebook who are, somebody just Facebook posted that they missed the building. I was like, that's interesting. I was in building 41 for many years. I felt like I was there forever. And I was like, that never dawned on me, like, I missed the building. So there's a conversation going on Facebook that I appreciate about Seeds as well. But I'm asking alumni, I'm asking our friends who are on the presentation tonight, would you please consider being a mentor? Would you please consider partnering with Seeds and helping us to find jobs for our great scholars? Please help us find paid internships and maybe job shadowing. We would very much like to help them along their journey. So when they cross the stage, we have alumni, we have friends, we have family of Firebird Nation that are opening doors for them. At this time, I'm going to turn things over to Dean Shetty and Mr. Rodney Trapp, who's the Vice President for University Advancement.
Thank you. Yeah, like you heard from some of my colleagues, a few of them couldn't join today. You know, like Dr. Lara Thompson, like she was busy. She has this big NIH center, you know, in the area of rehabilitation engineering, a new grant. And also you couldn't hear from Dr. Pawan Tyagi, who has a National Science Foundation CREST Center in the area of advanced manufacturing. Then we were also expecting Thabit Qasim, in fact, in the area of cybersecurity, you know, which is a NSA funding, and also we are setting up an NSA center also in that area, which will support our new programs in the cybersecurity. So as you can see, a lot of these programs are coming up. So we are turning to be a school from not only undergraduate, it's also graduate program with extensive research, with all the funding really helping the students, in various ways, in supporting them to get extra research, helping them to get jobs. And these days they are easily able to get jobs and they get internship. This NASA presentation, which Dr. Zhu did, has internships. So internships are set up through us, So we have these connections with NASA centers. So Dr. Zhu is able to send these students to various places, and then automatically it results in jobs and more opportunities. So overall, I wanted to emphasize that we deserve your support, and it will really help us to help the students actually in the financial need. That is where the funding will grow. And I really want to thank Vice President Trapp and Famika, for arranging this function. This is the first of its kind, so we had never done it. So I want to hand over to Vice President Trapp.
Thank you, Dean Shetty. This is the first, and it definitely will not be the last.
Yes.
I don't really have much to say because you all have said it. This is about sharing the story about all the incredible work, all the research that's happening, and the uniqueness of UDC and the School of Engineering and Applied Sciences. I don't hear, when I go to and visit other universities, maybe particularly the larger universities and even at other HBCUs, how involved the students are in research. Where can you go and actually graduate at the undergraduate level and be involved in authoring a research publication? That is a rare thing that happens, and that's part of the uniqueness and the special quality of UDC. And so this has just been an awesome and amazing presentation. I've learned a lot. It was exciting to see these ambassadors and hearing all the outreach that's being done in the public school system. It's amazing to see the energy in these young women that are also holding up the torch and representing, as Fo said, the diversity that we're engendering in our school. And so I invite you to please look more into what we're doing, consider supporting it, but more importantly, tell a friend, tell a neighbor to get to know UDC, find out what's going on there. There's a lot that's going on here. And we used to say this was the best kept secret. Now it's the secret is no more. So we want to shout it out loud and proud, the work that we're doing across the campus, and we hope you'll support it. Thanks.
Thank you. I also want to thank my colleagues who had been here on the panel, as well as the students who have been brilliant in their presentation. And if there are any questions, we'll be happy to answer any of those questions, and me as well as my colleagues.
Answering the chat, and I don't see any questions. The ambassadors addressed the one question, and then the relationship with regards to high schools. That was an important question. Again, I really appreciate that connection. Really want for DC youth, as well as their families, to know about the opportunities that are available to them at their public institution of higher learning that is celebrating, by the way, its 170th anniversary. UDC is the second oldest HBCU in the nation, founded in 1851 by the courageous abolitionist and educator Matilda Minor. And we're really proud about that. We are public, we are an HBCU, we are a land grant university, which means our mission is to be in all 8 wards in the District of Columbia.
Right.
providing services and programming. And we do that.
Mhm.
We can
Yeah,
do more with your help.
Yes, as you said, like we have now more participation with DC schools, and the numbers show that, like in the last 4 years, the number of DC students had been steadily increasing. You know, about 40% it has increased since 2017. You know, and it is on the upward trend. And with more partnership with the DC peers in various ways, we are planning a summer program along with our community college, you know, in certain areas, you know, cybersecurity and other areas. So the relationship is really advancing in various curriculum development, common courses, dual enrollment. All those efforts are being done. So I expect a major emphasis with many other schools. And Langford is really working with many schools and technical schools to increase that partnership. And you are right, like, so we'll have more to offer to DC public schools and other schools.
Thank you so much, Dean Shetty. And I really appreciate all of your research directors for being with us tonight. Thank you, VP Trapp, for your words of encouragement to our donors. Thank you for your perspective. I really appreciate that. Did you have any final words, Mr. Trapp?
Not really. I mean, I'm excited. This is an awesome program. This is also, this is the week of giving. And so this is the kickoff. This is actually our first event for the week. And so thank you, Dean Shetty and your faculty and staff for being yet again a trailblazer for this week and setting the pace. So now everyone has a high standard to achieve in order to. So we'll see what the rest of the schools and colleges are going to do. So because you've set the bar pretty high. So thanks again.
Thank VP Trapp, thank Formika for organizing.
Thank you very much. And thank you everyone for joining us. We're going to do this again tomorrow. If you're on my Facebook page, you'll see that tomorrow is the School of Business and Public Administration. You should have received the email, but please donate to SEAS. The link is in the chat. I can put it on the screen once again. If you go to SEAS's website, you'll see the Give to SEAS option there. We also have it on UDC Foundation. Please support this amazing program. If you have any questions, you can always give us a holler here at UDC, 202-923-0660, and we'll get your questions answered. But thank you for being with us, and we look forward to seeing you once we are face to face. Until then, everyone, please continue to be safe. Bye.
Take care.